Matt Scheckman here, aka Shecky the Techie, coming to you with another quick tech bite. Today we're going to be talking about analog audio levels, particularly the three different categories that those levels fall into, and the two different parameters that are significantly different in each of those categories and why. The two functions that a signal carried by a copper cable or some form of other electrical conductor have will be a voltage and a resistance or impedance. Those are the two we're most interested in. And based on those two values, your signal will fall into either what is called a mic level signal, a instrument level signal, also sometimes called a high Z signal, or a line level signal. Let's cover what those three things are. Mic signals. So a mic signal is super low impedance. It is the lowest impedance of all. It is roughly and should be 600 ohms impedance. Likewise, it is also the absolute lowest voltage. Mic level signals are anywhere from minus 80 to minus 40 dBV. Now, there's all different ways of measuring voltage and loudness and whatnot, but know that effectively that's the equivalent of 0.1 to 10 millivolts. Okay? And realize the highest mic level signal then, 10 millivolts, you're actually talking about 0.01 volt. That's a hot mic signal. That's why it needs so much gain. So that's our lowest voltage and lowest impedance, instrument level or high Z level. This is a weird combination in that it is the middle of the three as far as voltages go, but the highest of the three as far as impedance goes. Starting with impedance, hence why instruments is called high Z, because it's high impedance. The bare minimum normally for an instrument level signal is 10,000 ohms. More often, that number is between 47,000 ohms and 1 million ohms. Remember, by comparison, a mic level was 600 ohms. Now we're talking 47 kiloohms to 1 mega ohm. Significantly higher impedance. In fact, the highest of the impedance. Now, the mic level, you may remember, went up to a maximum of 10 millivolts, which was 0.01 volts. By contrast, the instrument level signal, not the line, that's the third, the instrument level signal, or high Z, is from 0.1 volts to 1 volt. So the lowest common instrument signal is still 10 times higher than the hottest microphone signal. This is why microphones need powerful preamps that are very different in their gain staging from what an instrument level might need. Now, you might be wondering, why do we want super high impedance? Well, traditionally, an instrument level signal is going to be a signal from an instrument, specifically normally guitars, sometimes basses, anything that traditionally uses a passive magnetic pickup. A very interesting thing happens with that. If you have low impedance on that, you tend to lose the high frequencies in your chain. If you're going into pedals, if you're going into fuzz, if you're going into your amp, even if you're going into your audio interface, if you bring it in as a line level signal, you can often gain it up enough. Bring it up to a line level, you'll be dealing with the fact that it will be thin, hollow, lacking definition in those upper frequencies. So for that very reason, you use a high impedance or high Z signal, and that lets you preserve those high frequencies while still getting the entire sound of the instrument. The third type of signal is line level. Line level, as you may have guessed by now, is going to be the highest voltage, the hottest signal, but the middle impedance. So right now, the two we covered, mic level, super low impedance, 600 ohms, super low voltage, maximum mic level, 0.01 volts. Next up, instrument, high Z. In that case, 47,000 ohms up to 1,000,000 ohms resistance, but a voltage range significantly higher than mic, but still from about 0.1 volts to about 1 volt. A line level is going to be from 1 or 1.2 volts at the lowest end up to as hot as 9 volts. However, whereas the instrument, practically, it's always over 10K, but normally well over 47,000, in fact, quite often close to or at 1,000,000 ohm resistance, the line level is between 10,000 and 20,000 ohm resistance. Significantly more than the 600 ohm of a mic cable, but significantly less than the impedance of an instrument or high Z1. The reason being, because it is actively fed, a line level is being driven by amplifiers or processing circuits or buffers or gain stages. But because of that, it's not going to lose the high frequency without having the super high impedance, as opposed to an instrument level. So those are the three types of levels. Now, next time we'll get into how do you convert from one to another? How do you know which one's using what? And what are the consequences of mixing and matching them? And how can you alleviate that by proper conversion? But for now, that's been quite a bit of information. The three levels again: microphone, instrument or high Z, line level. See you next time.